Hi girls. Today we're going to look at section 2.2, Algebra 2 with Trig, and it's find slopes of lines and rates of change. So last lesson we did a little bit about functions, and specifically we looked at linear functions, but we used things like the vertical line test, y equals mx plus b, to put it in that slope-intercept form. But now we're actually going to look at slope, parallel lines, perpendicular lines, and rate of change. So you've got a few vocab terms to start out with. The first is slope, and slope is defined as the ratio of vertical change to horizontal change. You might also recognize slope as m. So we use m to define slope, and you might remember it as rise over run, or y2 minus y1 over x2 minus x1. So all of those refer to slope. If two lines are parallel, then they're lines that they're in the same plane and they never intersect. So you might see this sign that refers to parallel lines. And those are two lines, and we have to specify that they're in the same plane. And it could be two or more. That never intersect. Perpendicular lines are two lines that intersect to form a right angle. A right angle is a 90-degree angle. You might also see perpendicular represented as that. And there are two lines that intersect to form a right angle. And then lastly, rate of change. We refer to slope as the rate of change, or rise over run, or y2 minus y1 over x2 minus x1. So rate of change is how much one quantity changes on average relative to the change in another quantity. So how much the rise changes in relation to how much the run changes. So how much one quantity changes relative to another quantity. In this next example, we're going to find the slope of a line. So the slope of m, in this case line m, of a non-vertical line is the ratio of vertical change, or the rise, vertical change, to the horizontal change, or the run. In algebra, we said m equals y2 minus y1 over x2 minus x1, or we said rise over run. So in the graph to the right, here's this line, and in order to find the slope of the line, or the rate of change, we look to see 2 points on the line, and we can do our algebra y2 minus y1 over x2 minus x1, or we can count the number of units we go up and the number of units we go across. So this first example, finding the slope. What is the slope of the line passing through 2 points, 1 and 3, and points 6 and 7? Let x1, y1 be the first set of points. So this is x1, y1 here, and x2, y2 be the second set of points. When you're calculating your slope, make sure to subtract them in the same order. It doesn't really matter if this is x1, y1, or if this is x1 and y1, just that you're being consistent and you're using the same point as the 1 or the same point as the 2. So in this example, we've got y2, which is 7, minus y1, which is 3, over x2, which is 6, minus x1, which is 1. And we get 4 over 5. So that means every point on this line, we go up 4 units, and we go over 5 units. And that's true about any point, up 4 and over 5. We can classify lines by their slope. So this first example, this has a positive slope. We always read slope from the way the line is moving left to right, just like we read from left to right. So this slope is positive because it's going up from left to right. So positive slope rises from left to right. A negative slope declines from left to right. Again, we're reading left to right as the line going up or down. If it's a horizontal line, that means it has a 0 slope. It's not going up and it's not going down. And if it's a vertical line, like this vertical line, it's undefined because you cannot divide a number by 0. And in the vertical slope, our rise, our change here, could be any number, but it doesn't change horizontally. So it would be some number divided by 0, which is undefined. There we go. So with a positive slope, that's when m is greater than 0. A negative slope is where m is less than 0, m being the slope. A horizontal slope, m is equal to 0, and a vertical slope is undefined. So in this next example, without graphing, we're going to see whether the line through the 2 points that are given, whether it goes up from left to right, whether it goes down from left to right, or is horizontal or is vertical. And so we can do that just by finding the slope of these lines. So we'll take our y2, we'll call this first point y1. So we know that the slope equals y2 minus y1, which is negative 2. So 3 minus negative 2 is 3 plus 2, divided by 1 minus a negative 6, which is 1 plus 6. So m equals 5 over 7. So is this greater than 0, less than 0, equal to 0, or undefined? This is greater than 0. So that means that this is a positive slope. In the second example, you can do the same thing. Let's call this x2, y2, and let's call this x1, y1. So we need to first find the slope to determine whether it goes up or down or is horizontal or is vertical. So y2, which is 2, minus a negative 1 over x2, which is 2, minus 2. And we get 3 over 0, which is undefined. So that means it's a vertical line. So in these next two examples, without graphing, so don't graph on your calculator and don't graph by hand, determine whether a line passing through these 2 points is positive, negative, well, rises or falls, is horizontal, or it's vertical. So does it rise, does it fall, is it horizontal, or is it vertical? Feel free to pause the video while you work. So in this first example, again, we can use this as y2, x2, and this as x1, y1. So we have the slope equals y2, which is 9, minus y1, which is 2, divided by x2, which is 7, minus x1, which is 2, and we get 7 let's say 9 minus 2, 7 minus 4. Made a copy error, so let's fix that. So we should have 9 minus 2 and 7 minus x1, which is 4, and we get a slope of 7/3. 7/3 is greater than 0, therefore it rises. In the second one, again, we can call this x2, y2, and this x1, y1. So our slope m equals 4 minus 2 divided by x2, which is 1, minus a negative 3, which is 1 plus 3, and we get 2 over 4. And we can simplify that as 1/2. And 1/2 is positive, therefore it rises from left to right. In this next section, finding slopes of parallel and perpendicular lines. So parallel lines are, again, lines in the same plane that never intersect. So the lines are parallel if and only if they have the same slope. If they're in the same plane and they don't have the same slope, at some point, they will intersect. So the slope of line 1 has to equal the slope of line 2. The lines are perpendicular if and only if their slopes are negative reciprocals. So m1 equals negative 1 over m2, or m1 times m2 equals negative 1. So lines are perpendicular if they intersect at a right angle. This little box at the angle indicates 90 degrees. So if you see that, that means a 90-degree angle. Classifying parallel and perpendicular lines, you need to, in these next couple examples, we're going to tell whether lines are parallel or perpendicular. So the first one, a line passing through, so first we need to find the slope of each line. So line passing through -3, 1, and 2, 5. Tell whether line 1 and line 2 are parallel or perpendicular, or neither. So the first slope, we're going to say m equals 5 minus -1, or 5 plus 1, over 2 minus a -3, or 2 plus 3. The line of the first slope is 6 over 5. So that's slope 1. Slope 2 is 1 minus -4, 1 plus 4, divided by -3 minus 3, which is equal to -5/6. So these two have opposite reciprocals, therefore they are perpendicular. We also see perpendicular denoted like this. Okay, try the last example on your own. Tell whether the lines are parallel, perpendicular, or neither. Feel free to pause the video and then return when you're done, and I'll walk through the worked out solution. So the slope of the first line equals y2 minus y1 divided by x2 minus x1. So the slope of the first line is 4 over 2, which is equal to 2. The slope of the second line is equal to 5 minus 6 divided by 22 minus 24 is equal to -1 divided by -2, which, if we simplify that, that's 1/2. In order for a line to be parallel, it has to have the same slope. In order for a line to be perpendicular, it has to have the negative reciprocal slope. In this case, we just have the reciprocal slope. So in this case, these lines are neither perpendicular nor parallel. All right, please, if you have any questions, jot those down now and we can go over them in class tomorrow. Thank you, ladies.